Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh to our PT doctor, which is Dr. Nadia. And today we are from group 2 and we have 7 members. Today I would like to introduce about the journal that we have already read, which is about dietary responses of the Brackish Cladoceran, which is Daphniopsis Australis. They feed on different species algae. So Daphniopsis Australis, they feed on 3 different algae species, which is T, N, and I. So T is stand for Tetracellular, N is stand for Nanochlodopsis oculata, and I is stand for Isochrysys tahitiae. Next, for your information, Cladoceran species, they consume algae, fungi, bacteria, and organic matter. But Cladoceran, the main food for Cladoceran is algae because of the size, mortality, and nutritional value. But this species also can choose another food because of abundance of algae is low, or algae size is or cannot be handled by animal feature. From my research, which is additional information about the Cladoceran. Cladoceran is largest group of zooplankton that have biggest potential to regulate phytoplankton. Daphniopsis australis is parthenogenic a short generation time, and from this journal, this considers that the Australis as a model species for saline water and to examine responses for food manipulation. Yes, betul. From this journal, also we can get new information about the relationship between the Australis and their food organism. And the last one is this information. All this information is important for further studies in physiological responses of this species. So that's all for introduction of this summary. Next, we go to methods and material.
There are 4 material and methods that used in this journal. Okay, the first one is culture of algae. The green algae, Tetracelmis succica, was cultured in sterilized seawater that contained the aquasol medium. Then, while Nanochlodopsis oculata and Isochrysys tahitiae were grown in F2 medium. The size of this algae was in range 8 to 10 micrometer. Then for Tetracelmis succica is 5 to 6 micrometer, and for Isochrysys tahitiae is 3 to 4 micrometer in size. These algae were cultured in a series batch cultures with inoculation every 2 days to ensure adequate algae supply at the exponential growth phase over the experimental period. These algae also contain various forms of PUFA, which is polyunsaturated fatty acid, which are essential for growth. Okay, next for the second one is stock culture of Daphniopsis australis. Each algae species was harvested in an exponential growth phase to feed Daphniopsis australis every 2 days to maintain the density of 105 to 106 cells milliliter -1 in the animal culture media. Okay, then the population density of Daphniopsis australis in each container was maintained below 1000 individual liter -1 to reduce overcrowding. Since then, a laboratory population was maintained at 20 to 22 degrees Celsius and 22 to 23 PSU under a 12-hour dark and 12-hour light regime at 1800 LX. This algae density is considered optimal for mass culture of Daphnia species.
A live light method was used to examine the Australis' responsiveness to various diets. Prior to each feeding, algae cells were taken during an exponential growth phase and counted on a hemocytometer under a light microscope. For most Daphnid species, this algal density in each diet combination was higher than the incipient limiting concentration. Individually, the first generation of neonates were acclimated in a jar containing 50 mm medium from each food treatment. To account for phenotypic plasticity and maternal influences left over from stock culture, only third generation animals were included in the life history research. All neonates younger than 24 hours were individually inoculated into a jar containing 50 ml of medium for each food treatment. Growth was measured daily on each individualizing the distance from the anterior part of the head to the end of the carapace. Population parameters including net reproductive rate, generation time, and intrinsic growth rate were estimated. 2.4 Statistical Analysis. The statistical software SPSS was used to analyze the data. P less than 0.05 was used for all significant levels. The impacts on each life history variable were determined using a one-way ANOVA. The Turkish HSD test was used to compare the differences between groups.
Okay, now I will continue with the result. The animal longevity is significantly different between the type of algal diet. Female feed on the end, oculate alone life longer than those feed on eye, titan alone. However, the longevity of female feed on end, oculate alone were not significantly different from those feed on the combination. Similar, the longevity of female feed on eye, titan alone did not differ significantly from those feed on eye. Then for age at first reproduction (AFR), the maturation of female was significantly affected by algal species. More specifically, female feed on eye by and mature significantly early than those feed on the algae combination. However, the time to reach maturation was not significantly different between female feed on T.
For the third result is egg development time (EDT). The egg hatch faster in female feed on monospecies of N. oculata, Ithatian, or T. suchicha than in those feed on multi-algal species. However, there were no difference in EDT between female feed on single algal species or between those feed on multi-algal species. The lower growth rate was found in female feed on T. suchicha on and did not differ from those feed on multi-algal species T. multi-N and I. multi-T. So the growth rate for female feed on either model algal, Ithatian, or multi-algal species I mati N, I mati T, T mati N, I mati T, mati N were not different. So for the fourth result is total age class. So the highest number of class occur in female feed on monoalgal T. suchicha, while the lowest number of class occur in female feed on mono Ithatian. So the number of egg class did not differ between female feed on monoalga and oculata mati algae, T mati N and I mati N. So the last for the result is total offspring. The female feed on T. suchicha product the maximum number of offspring, followed by a significant reduction in T mati N treatment. The minimum number of offspring was product by female on feed on Ithatian. The number of offspring was further reduced in female feed on N. oculata, although the total number of offspring product by a female was significantly affected by algal species.
I'm going to talk about the response to algae species at the population level. There are three responses. The first one is net reproductive rate. Reproductive rate was significantly affected by feeding on different algae species. Specifically, females exhibit a greater rate when fed on T. suchica than those on other algae combination. The second one is by generation time. The generation time of the Australis was significantly affected by feeding on different algae species. For the third one is intrinsic growth rate. Algae species combinations significantly influence the intrinsic growth rate of the Australis. However, there was no significant difference in R values when animals fed on the monoalgae, T. suchica, or the multi-algae.
We move on to discussion. The life history, features, and fitness of the Australis are greatly influenced by multi-algae species. This shows that the mix of algae species might influence by population dynamic of these saltwater Cladocerans. This study, however, does not prove that multi-algae are superior to monoalgae for growing the Australis in captivity. So, for the first one is longevity. Herbivory Cladoceran generally graze on algae, hence the algae composition in the medium influence grazes survival. It was reported that the longevity of Moina macropopa was the longest, and when fed to Pseudosdemus in Carasatulus, followed by Anchytrosdemus convolus. The longevity of these celebensis was the longest when fed in on Tetracermis gracilis, followed by Isocrosis valbana and Cetoceros calcitrans. These results are consistent with the present study where the longevity of the Australis was longer when fed to monoalgae to T. sessisa than those fed either with Enoculata or I. tahitian. Interestingly, the combination of multi-algae species produce intermediate longevity. Okay, next is development, growth, and reproduction. The three algae species used in this study are considered suitable for growth and reproduction for many zooplankton species. T. sessisa supported the highest reproductive output of the Australis, but hampered by body growth rate. Enoculata and Iethetian alone support more on animal somatic growth than on reproduction. A possible explanation for growth discrepancy between algae species is that the Enoculata diet contains 6.3 times and the Iethetian diet contains 2.8 times more carbon than the T. suessisa diet. And this study suggests that while the T. suessisa and Oculata and I. tahitian possess suitable nutrition for zooplanktons. The highest reproductive output of Dietaries occur when they were fed on T. sessisa rather than on Eparish and Oculata. So we move on to impact of algae species on the Australis at the population level. Population parameter can better reflect animal responses to the environmental change than individual parameters. The Australis exhibit a pattern of dietary response similar to the end of one report. The Australis exhibit a pattern of dietary response similar to the one reported for D. levis. In Daphnia coculata, the R value is highest when fed on C. acutus due to fast maturation and maximum reproductive output of the animal. In a copypot, Bordetella triarticulata, the population growth is maximized through either minimizing AFR using monoalgae Critomonas species. As the result, high population growth of D. australis was achieved by feeding either on the monoalgae diet, T. sessisa, or multi-algae diet. So the last one is monoalgae diets versus multi-algae diets. Pinana and Acacia singensis grew faster on multi-algae diet, which is I. tahitian and Tetracermis chui, than on the monoalgae diet. T. sessisa was beneficial for reproduction and longevity, while Enoculata and I. tahitian were beneficial for somatic growth and early maturation. The superiority in growth and reproduction of the Australis disappeared when they fed on the mixture of these three algae. And the last one is the positive role of T. sessisa on the animal reproduction is depressed by the introduction of other two algae species, which is Enoculata and I. tahitian.
Last, for the conclusion part of the whole journal, is the type of algae species significantly affected the life history of the Australis. While T. susica was an excellent food to support animal survival and reproduction, the results of this study provide a guideline for choosing algae to grow the Australis and also advance our understanding on diet regulation of the population dynamic of saline water cladocerans in heterogeneous food environments. That's all for the conclusion of this journal. Thank you.